As we start to build our game, it's important for us to think about some basic design parameters. The type of game we're building is known as a shoot-'em-up or shmup. The way we're going to lay out the screen is to have the game be on the left side, but then also have an information display on the right. We'll keep the full window width at 1280 with 720 pixels for the game window and the remaining 560 pixels for the information display. The height will remain at 960. You can do whatever you want for your game. The goal for this video is to get some graphics onto our screen. We're going to have a background that indicates the game window, and then we're going to put a spaceship on it. An important note is that I'm not much of an artist, so all my graphics are fairly basic. Later on in the video, I'll point you to some potential resources if you want higher quality graphics. Let's start with the background. Here's the one that I chose. I just went to a website that makes color gradients and picked something that felt like it was going deeper into space from bottom to top. The image I have is not the same size as the desired game window, so we're going to need to stretch it out to make it fit. And we'll deal with that when the time comes. You can draw in stars and planets and other things, but you'd want to pre-scale your image so that your drawings don't get distorted. And if you're really ambitious, you can apply the animation concepts that we'll use with sprites to the background image and have an animated background. We'll talk about animations in a later video. If you're not artistically inclined, but you want to get access to higher quality graphics for your game, there are websites out there where people have created video game art and have made it free for others to use. One such website is opengameart.org. You can use the search option at the top right to look for something like space background, and it will give you a collection of images that you can use. Make sure you pay attention to the license. Some images will ask you to include an attribution, which you can put as a comment in your code. We also need a spaceship. Here's one that I drew in MS Paint. Again, you could probably do better, or you can just look for art online and make sure you ascribe proper attribution. I went with this because it's something quick and easy and falls within my skill set to create. Notice that I made the background black. This will be important later. In order to get these into the game, we're going to have to do a bit of prep work. If you look at the folder for this video, you'll see that there's a new subfolder called IMG. This is where all of our images will go. The reason for this folder is really just about organization. Let's take a look at the new code. We have a submodule that we're importing called path, and it comes from the OS module. What this will do for us is that it will simplify how we keep track of files by letting us build the file paths in an easy way. We can see this in the new command that sets up our image directory. What this command says is to go to where the main Python script is located, and then look inside the IMG folder for the images. We now have a section for loading graphics in the initialization. It's most efficient for us to load all the graphics at the initialization step. Notice that both of these commands have the same basic shape. The left side of the equal sign is the name of the image, and the right side is the command that actually loads the image. The only parts that should change here are the variable names and the file names for the image. After we load the spaceship image, we're going to set the color key. The basic shape for Pygame is a rectangle, but we have a triangular spaceship. If we don't set the color key, Pygame will draw the black parts of the image, which creates something that looks like this. Setting the color key to black tells Pygame that the black parts of the image shouldn't be drawn, which gets rid of these black triangles. Let's focus on getting the background set up. So far, we've loaded the image into memory, but it's not the right shape. So we need to tell Pygame to stretch it out to the correct size. The next command gets the rectangle that corresponds to the image we just created. The reason we need to do this is that all images are drawn on top of rectangles. The getRect command is convenient because it calculates the exact size of rectangle we need to contain the image. Typically, we'd also want to adjust the position of this rectangle, but the default position for the rectangle is to have the top left corner at 0, 0, which is exactly where we need it to be. The background won't be drawn until the rendering phase of the game loop. The command for just drawing an image is the blit command. Notice that this takes two parameters. The first parameter is the image, and the second is the rectangle on which we're drawing that image. And since the rectangle is perfect for the image, we don't have any additional concerns about the execution of this command. For the spaceship, we are going to use a sprite. Sprites are basically the objects in our game universe. The background is just an image, but the spaceship needs to respond to input and interact with other sprites. Because it needs to be able to do all these things, the code is a bit more complex. The first thing we need to do is define the sprite class. We're going to do this just after loading the graphics. The name of this class is Spaceship. Notice how the sprite class starts with a capital letter and how the indentation shows the scope of this part of the code. The sprite class is used for all the game objects of a specific type. Right now, we'll only have our spaceship, but later on there will be lasers, enemy probes, and explosions, and each of these will be its own class. The class holds instructions that define its behaviors. These commands are known as methods. The init method is run every time we create a sprite of this class, and it sets up many of the basic properties that we want our sprite to have. The first command just tells Pygame to give it all the basic properties of a sprite. We're going to treat this as a black box because there's a bit too much to explain at this level. After this initialization step, we need to start adding in the properties that we care about. These first commands set up the graphics. Notice that the commands are in the form of self.something. These are commands that update a sprite's information about itself. For example, every sprite will have a specific graphic and position, and the sprite carries this information inside of itself in this manner. Self.image tells the sprite which graphics to use for itself. Since we've already loaded this earlier and set the color key, we don't have any more work to do here. We also have to get the rectangle as we did for the background. Remember that the image is drawn on top of this rectangle. And since rectangles contain information about location, we use the rectangle to indicate where the sprite is going to be drawn. And the last couple lines do this. The first one puts the spaceship in the middle of the game screen, and the second one puts it towards the bottom, but not all the way down. We'll say more about the different ways we can position rectangles in another video, but if you want to think about this for a bit, you might be able to figure it out by just studying this diagram and playing around a bit. We're not quite done yet. This is the code that we need to set up the sprite class, but it doesn't actually make a sprite and put it on the screen. It's just creating a definition. We'll take a quick look at these parts of the code and save the longer discussion for how this works when we're starting to have more sprites to play with. We start by making a sprite group. This is basically a container that will hold all of our sprites, and later on we'll make different groups for different types of objects. Then we create the sprite. It's going to be called player, and this line shows that the player is a spaceship sprite. Then we put the player sprite into the group that we created. Lastly, when it comes time to render the graphics, we tell Pygame to render all the sprites in the group, and since our spaceship is in that group, it will get drawn to the screen. These last steps probably flew by pretty quickly, but that's okay. We'll have more time to talk about it in a future video. The logic of sprite groups makes much more sense when we have multiple sprites on the screen. But before we get there, we're going to look at how we can bring this sprite to life.